Hi, I'm Miss Hearn. Let's get started. In this video, we're going to talk about when sets are finite or infinite. And you might already be familiar with these terms. Finite means that a set doesn't go on forever, and infinite means it does go on forever. But to formally define them is a little bit less straightforward. So let's take a look. In order to define them, we're going to have to know the term whole number. The whole numbers are the numbers 0, 1, 2, 3, 4, 5, and so on. Ironically, the whole numbers are an infinite set. It goes on forever, following the pattern of increasing by 1. And we're going to use the idea of the whole numbers to define finite. A set is finite means that the number of elements in the set is actually a whole number. If we can count the number of elements in a set and we can get a whole number, a number out of the set of whole numbers, then we call it finite. Otherwise, if there's no particular whole number that gives the number of elements in the set, then we call it infinite. So to really get into what that means, we're going to look at some examples of some sets. Let's look at set A. Set A is the set containing the elements 2, 4, and 6. Now, if I asked you, is that a finite set, you'd probably say yes, because it doesn't continue on forever. But another way to think about it is there a certain whole number that is associated or that gives the number of elements in the set A? And the answer to that question is yes. We can count the elements in A and we can see that there are 3 of them. Since we can say that the number of elements in A is 3, also called the cardinality of A, and since 3 is a whole number, this fits our definition of what it means to be finite. Now let's look at set B. So set B is a very special set known as the empty set. It can also be represented as a circle with a line through it. And so how many elements do we see in B? Well, there are none, right? So there are 0 elements in B, and we can write that as the cardinality of B. The number of elements in B is equal to 0. Is 0 a whole number? Yes. So since we can give the number of elements in B as a whole number, this fits our definition of finite. How about set C? So set C has something called ellipses in it, the 3 dots that indicates a pattern continues. And sometimes people think that if we have that, then it's automatically an infinite set. But in fact, if there is a beginning number and an ending number, then those ellipses are not necessarily indicating an infinite set. Probably not. So in this case, we would have what? Let's write it out. This is 2, 4, 6. The pattern is that they're increasing. The elements of the set are increasing by 2 each time. So the next number would be 8, and then the next number would be 10. Let's count how many elements are in the set C. We can see that there are 5 elements in the set C, or in other words, we could say that the cardinality of the set C is exactly the whole number 5. So that fits our definition again of being finite. Now let's look at set D. The set D is 2, 4, 6, and so on with no end. So if I were to try to list out the elements of the set D, I would never stop. So intuitively, you probably realize that this is an infinite set. It just keeps going. There is no largest element. Even if I listed it out to 1,000,000, there would still be another element, 1,000,002, in this set, and it would continue after that as well. Is there a whole number that we can associate with the number of elements in this set? No, because no matter how many I find, I can always find one more. Set D is what we call an infinite set. So in your homework, if you're one of my students, you might see something like this in your MyLabs. Identify the following set as finite or infinite. And we're told that the set is the set of all x such that x is a natural number greater than 60. The natural numbers, by the way, are the numbers 1, 2, 3, 4, and so on. They're also known as the counting numbers. They can be represented with a bold N. And we're talking about the natural numbers greater than 60. So in this case, we would be talking about the set that starts with 61 and then 62 and then 63 and so on. Notice it doesn't give us an ending value. It goes on forever. So intuitively, you probably realize that this is an infinite set. But in my labs, they want us to explain why. So what we need to do is to select the reason why. So we have two options here for infinite. And you can see that the set is infinite because the number of elements in the set is not a whole number. It fits our definition of what it means to be infinite. I hope you found this video helpful. If you did, please remember to give it a thumbs up. That helps other students to find the video. You can also subscribe to Miss Hearn Mathematics for more math videos.